how our slab is generated. And the more better view in this, we have an OpenGL view, graphic mode option, graphic mode, and graphic mode OpenGL view. Press yes. Now we are looking at the slab in the OpenGL view. Let's rotate our model. In this view, you must check that how your slab is connected to the beam. This is very important to check this connectivity of the slab to the beam. Now if we see closely, our slab is connected to the center of the beam. No, it's okay. The slab is not connected to the center of the slab. This I mean the beam is connected from the top to the slab. This is called this system is called T-beam. This is a T-beam system in which the slab is at the top and the web is at the bottom. So you must check this thing, that the slab should be at the top and beam should be connected from the bottom of the slab. This can be controlled by the insertion point. Okay, at this moment we have very less thickness, so we can't see it properly. We can't see this properly because the thickness of the beam is very less. Okay, so we want to confirm this. This is very important in our model, and we will confirm this by, first of all, make it 3D. Select by property and select by the frame section, and by default we have B12 cross 10. Select all the beams. So all the beams are selected with us. Now assign frame section and select a heavy section of 24 cross 15. A heavy section is being assigned to the frame, and we have the frame as let's check by the, oh my god, let's save our work here. Okay, now it is a good practice to save your model, so it is a good practice to save our model. We will save our model. Okay, and as I have file, save as, and you can save by, right now I have saved by 3df.sdb, but you can save by any other name. Okay, so now switch back to classic view. In the classic view, select by properties. In the properties, select frame section. In the frame section, I have defined this frame section. Select all the frame sections. Assign frame section. I want to increase the depth so that I can see connectivity 24 cross 15. Now looking at 24 cross 15, let's zoom this model and check our connectivity. Here the slab is not connected by the top. Okay, the slab is connected from the slab and beam are connected by the center line. Got it? So you can confirm this because there is some clearance which we can see here. Okay, so if you can see from the bottom, you will see this more clearly. See, from the bottom, if you see, the slab is the area which is appearing, which is offset from the slab, is this thickness is the same as that from the top. So the slab is connected from the center point of the beam. We need to change this because in our model we have a T-beam system in which slab is connected over the top and beam is on the bottom. Okay, Now go back to the 3D view and select again, select your property and select the frame section, which we have right now assigned 24x15. All the frames are selected. Assign frame insertion point. Insertion point control the connectivity of the slab with connectivity of the frame with the slab. Right now it is centroid connectivity. I'll convert this to the top center, which is number 8. By top center it become a T-beam system. If I connect by the bottom center, it become inverted T-beam. But right now I will connect it from the top center. Press OK. Now check the connectivity of slab and the beam with each other. If you focus, the slab is now at the top, and if we rotate this a bit, we can see the slab is at the top, and the frame is connected from the top to the center of the slab. Okay, and there is no thickness of the slab because it is a 2-dimensional element. Thickness is defined only in the formulas. Got it? So all the web is now right below the top of the slab. Now this is the model which we need. This is what we need. So this point is very important when you make a slab beam system, in which you consider the T-beam is below the slab. This is. Now let's go back to our model. Next step is to define the. We have defined the sections. Now we need to define load cases and save our model as well. Define load pattern. In the load pattern, define a live load. Add type as live load and add this pattern. Press OK. Now define load combination. Add default design combo, and the combination is based on the concrete frame design. Right now we have a code of ACI 31805 along with IBC. So the combination of the concrete frame design will be based on ACI code in IBC, which is for the dead load we have factor of 1.2, and for the live we have a factor of 1.6. IBC stands for International Building Code. So in UD-Con 1 we have 1.4 of that. UD-Con 2 we have 1.2 of that, 1.6 of live. Select this, modify and show. That is 1.2 of factor and live is 1.6. Press OK. Combinations are made. Now what we need,